Welcome back from the break. I hope you had a good chance to interact with other people, to network, to visit the sponsors, maybe get a good coffee from the barista stand. Now, going multi-cloud, we've already heard that there might be some complications. However, before we start, this talk is different from the others in that Michael wants it interactive. That means you can ask questions. Michael is going to repeat them for the video and then directly answer them. Sure. Without much further ado, Michael Gläss, Chief Product Architect at Dynatrace.
Hi, thanks everybody. Big crowd, it's very interesting. This is a sharing talk, so basically I will try to share our experience, some information with you about multi-cloud. So my first question would be up to you. Who is using at least 2 cloud vendors? Okay. Oh, I would say 20% till 25%, so maybe you know already partially what I will talk about. You have maybe already some experience, so for all of the others, of course, maybe something interesting to add to your knowledge. And also, if you have any questions, please interrupt anytime. We can have an open discussion. There's enough time, it's 30 minutes in total, the session, so don't worry. What we will talk about, that's a bit delayed, just a sec. Okay, this is the agenda, what we will talk about, classic myths about multi-cloud. We will also go through general consideration, also, of course, what we learned at Dynatrace, what are significant pain points at Dynatrace, and what are potential solutions you could take with you. Okay, classic myths. Who didn't hear that before? It's so easy to go multi-cloud. You can simple switch. There are no specific costs around it. Just add a cloud vendor. For sales safety and other reasons, just go double and no problem to get that done. So these are the classic sentences that are typically advertised if it's around multi-cloud, and please don't adhere to them. It's definitely not the case that this is that easy, and that's what I will go to. So general consideration when you go multi-cloud is, why should you even go multi-cloud? Because is one cloud vendor not enough? So do you have specific business reasons? Then it's the only driver basically that moves you to multi-cloud. Do you have a regulator that forces you, for example, no, for fail safety, you have to have second cloud vendor, maybe another possibility to decide on multi-cloud, but otherwise, never go multi-cloud if you don't have to. Never ever. Because it makes life, of course, a bit more complex, a bit more work to be done and so on. So let's dive into that. So in general, what you need to think of course, is if I have 2 cloud vendors now, so where will I develop? Where will I basically at the end have my main development? What about testing? How do I stage getting the stuff to production, all the rollout cycles about multiple vendors, specifically then also, what are my technicians? Do they know all of that? Do they know all the techniques and services that are on the second cloud vendor available? So a lot of questions basically that you are confronted with if you're coming to the idea to go multi-cloud. And we as Dynatrace are supporting 3 cloud vendors, so AWS, Azure and Google. So obviously we took the decision to go multi-cloud and had certain answers, of course, also to these questions. So for development, it's not easy. For development, typically it's about local development, cloud development and virtual developments on the local machines or on the remote systems, because you need certain sandboxing, you need to try the services and have also remote the cloud vendor services. Then also, of course, if you develop, yes, we have a main development area because it's quite an effort if you spread across all the cloud vendors. So you need to have your main workforce basically running on one vendor that says, okay, all the default Java stuff, for example, I'm building with the services and so on, I do first on one, and when it comes to the specifics, then I break out to the different areas. And so going forward, we have also answer, of course, to the staging. So you see there are significant effort on amount of development stages you need, hardening stages that are multiplying, of course, by the different cloud vendors, and then X production environments, depending on where our customers, where we provide the platform. Going further, what was the answer basically also to say, okay, we need to get the stuff deployed. So we have an internal developer platform where we power up, where we group the people together, where we also did a reorganization recently around it so that we strengthen that exercise and get the underneath layer basically for the rest of the huge developer community on top basically implemented. So going forward, of course, you also need to think of what delivery tooling, what development tooling do I need? So classically, you can say, okay, take something from the cloud vendor that is very cloud vendor specific, yeah, but then you end up most likely with 3 different cloud vendor tools that are then very specific, and you need people trained on all of the tools. You can go also the low-level path so that you say, okay, I use a SDK from a vendor, for example. I purposely wrote here, for example, the AWS, because that we are using as well. So then maybe you want to go abstraction because you don't want to talk to all the APIs. You want infrastructure as code, so there are different solutions around it. So you come away from 3 different implementations to 3 different configurations because it's still different, it's not the same. And then you move further. So there are hybrid platforms, for example, that are helping you to get your deployment done. And also here you need to think, okay, then I have a vendor. I need to be specific towards this vendor, to these solutions, for example. Do I want that? And what about reliability? What about resilience and so on when I'm now dependent on something else? And as a last, do it yourself, which basically can combine any of the previous options in the specific set that shapes you exactly what you need. And what do you think? Dynatrace path was do it yourself, because we are combining basically all of these parts. So we have some pieces that we take from platforms, we have some elements we basically do with infrastructure as code, as well as for high-speed system interaction, for example. If you need faster bucket or something, you don't want anything in the middle. You want directly with the API vendor, for example, to interact. So you use the library, for example, from the API vendor. So these are all considerations, but what is actually the effect when you go multi-cloud? The effect is that a significant increase in different areas of work to get done. And that comes up to 70% for the platform team, because many of the services that we are leveraging are not exactly the same. So you need to configure, script all the deviations basically you have in between the cloud vendors. And also the development team at a certain degree needs to adjust. So to have it completely shielded from the developers would be very complicated, especially if you with low-level services are interacting. So either you would need to buy another layer or you get it into the software. And with all of that, basically you add a significant piece of work where you need to balance out, is that actually your benefit? As I said in the beginning, don't go multi-cloud if there is no significant business benefit or a reason for it. So what are obvious differences? Obvious differences when you go to the cloud vendors are the portals, the UI, the control planes. But then it comes obvious, yes, but not nice when it comes into the implementation, more in the direction of IAM, networking, what images and services you have available, even down the road, what regions do you have available that you can choose for the hosting in the end of your software. And this is a significant driver and a complex scenario when you go there, and I will show it also later in more details, basically, where this comes as a burden then. And last point is a very important point, is the pricing. Every cloud vendor has obviously its own pricing method, its own prices for the services, and as well its own way how to basically give discounts or allow pre-orderings and so on, reservations. So here you also need to be careful that you not suddenly end up with something on the second cloud vendor that costs you double. So what are relevant differences basically for Dynatrace? In Dynatrace, we use, for example, machines that are underneath of Kubernetes that need to have a specific shape. So we like memory intense and CPU powered machines. So this is one set, for example, where we did the comparison. And you see, because I tried to put it together, different attached storage, different network behavior, the pricing is slightly different. So just because on top is standing, yes, you get 16 vCPUs and 120 gigabytes of storage, it doesn't mean basically you get the same machine, because cloud vendors are not magic. They have the same as a data center at the end, what all of us had in the past. So you have a rack, you have a server inside, you have virtualization, and they need to adhere to the hardware basically that they're buying. And that's why also the offerings most likely look different. The problem with that is, if you have, for example, software that needs to run with attached specific storage, and you need a throughput, and you have between the cloud vendor a different set of throughput or different variants, you might end up with a different performing platform, with a different performing service, just because you host on the other cloud vendor, no matter what basically your service is. So it's maybe even doing exactly the same, but it's just hosted on two different types of infrastructure. And that's to a certain degree not changeable. So you have deviations, as I wrote here, up to 70% in storage, in throughput or networking. Especially in networking, for example, we have heavy throughput, for example, log streaming or other things, heavy throughput related. And if you're not getting the bandwidth, you have a natural limitation on that services. So this is a problem statement you need to think of, because if you started like us, for example, on AWS, it looks pretty. Now you go to Azure and suddenly, oh, I get half of my network. What does that mean for me? And the implication out of it is most likely I need to make a different shape of my underlying platform hosting my software. Because suddenly I don't need 12 instances, I need 18 to balance that, to get still the work through and the things processed. Because I have no chance to increase basically the upper limit of the assigned machine here. And the last point is also important is the pricing, which I pointed out before. So there are deviations around 25%, I would say, from the list pricing. And I doubt that you are able to sell your service for 25% different just because it's a different cloud vendor. Nobody would buy that and say, yes, please host me on Azure instead of Google or on AWS. And yes, I pay 25% more. So you have to eat up basically the cost and calculate smart and connect with your cloud vendor to have dedicated budgets, pricing, pre-calculations, and everything in place to at least come to an equal. You will never come to an even, but to a like equal price segment. So this is very important basically for us, especially with specialized machine types. Also when going forward, you have significant issues when you have specific machines you rely on, because you need the power either of processing or the large storage because you use it as cache, for example, in memory, that these machines are not everywhere available. Not even on the cloud vendors that offer the machines are available in each availability zone. So we learned with some cloud vendors that in one region, they had 2 availability zones ready with these machine types, but not the third one. What do? I cannot go down basically with my resilience. If I have a 99.95 or 99.99, I cannot go down and say, yeah, happy, I have 2. That calculation doesn't work. So this is something also to consider and to take in mind when you are basically going multi-cloud, that this is a risk when you use specific machine types that they might not be available. And last sentence also added here, when you go then into the ARM machines with our ARM CPU base, this is even more rigid, more restricted available, because these machines are expensive, new technology, they have a higher performance to a lower price set, so they are very attractive for us. Yeah, but unfortunately, hostable maybe in 12 of our 20 needed regions. And then I end up with a platform again, complete different shape in different regions that need to be operated. And that's, you need to be careful, because then you put a lot of variations basically in your delivery platform, in your hosting platform, which you later have to work with. If something goes wrong, for example, who knows why this specific shape in that region is now not working. Okay, another problem statement, for example, is PostgreSQL. We love to use PostgreSQL because it's a perfect database for simple storage for us. And what you need to think with multi-cloud vendor, the versions first. All the versions come to a different cycle, so you need to be able to have a very flexible delivery cycle in when you upgrade which database. You need a complete decoupling basically of the database in order to adhere to the different cloud vendor standards. You might say, yeah, they're anyway long supported and many years and so on. That's true, but at a certain point you will have to switch. And that comes then also to the major version. So some vendor, for example, allows you meanwhile to have an interruption, mostly interruption-free switch. In other cloud vendors, this is a nightmare. You either build up a complete database next to the existing database, make replication, and then switch by yourself with handcrafted scripts and all the other things. But there is no one-click solution that you just in your Terraform say, I want the next version. Because what would happen would be on our side, a direct operation interruption. As one database server shuts down, and eventually in 10 minutes the next one comes up. That's not doable. So also coming then into the replication, the HR setup for high availability and also other assets, the vendors are quite different. That's why I also placed the models. So if you go for Aurora, if you go for an Azure SQL or a Cloud Store in the end from Google, the products all say, yeah, we are Postgres. But this is just basically the database engine with the database dialect. AWS, for example, ripped out the storage layer completely and replaced it by an own implementation. So it is different. And it's also different how you treat it, how many instances you get. For example, with reader-writer concept, we have sometimes the problem that, for example, our writers are overloaded and because there are not enough readers. So in one cloud vendor, you can easily manage that. In another cloud vendor, that's not so easy to be built out to have just 20 readers next to it. So there are significant differences. And then also backup restore procedures, for example, for disaster recovery and so on, are all different on the different cloud vendors. Coming also to Kafka. So here I can go a bit off basically because there are cloud vendor offerings, different type of. At the end, we decided to host Kafka by ourselves on Kubernetes with Streamsy due to the fact that the shaping, the sizing, what we get from the cloud vendors with the specific machines and the association mix that we have with different topics, types, and so on, was no exact match. And then we would have 3 complete different services at the end of the day of the different cloud vendors to maintain. And to overcome that, basically we said, okay, we would love to have Kafka maybe as a service, but we built our own service. Also interesting, for example, was quite a pain point because it's a security issue that the identity access management integration. So for example, for a cache, if you use Redis, there was quite some time now on Azure, no IAM integration. So the ACL feature with IAM integration simply didn't exist. So you build on the first cloud vendor saying, yes, I use the service, I have isolation, I have on one Redis cache various type of consumers with different storage, and then I come to the next cloud vendor and say, oh, my isolation is gone. My security is gone. So you need to split out basically on the other vendor and say, okay, then I need to have multiple instances if I still have the requirement on the isolation, which is pricey. Any questions till now? Anything? No, everybody short for lunch already. Good. Let me share some solution approach. So how did we address that basically? First of all, building the delivery/developer platform. So having a team that is unified, that is specialized on different cloud vendors, reorganizing a large entity. With large entity, I mean, we have, I think, 300 plus people maintaining all the underlying techniques, procedures, cloud vendor services, and so on. We have specialty teams that, for example, maintain the Kafka service. So we have also services teams that then can take care of different service areas. And together they build the delivery platform/developer platform where then the other teams that develop on top can just consume with simple requests, processes, and having a, how shall I say, a bit easier life. So also for you, maybe interesting to take with you, you also should pay attention to disaster recovery, because in each of the cloud vendors, disaster recovery is slightly different. How you implement that, what recovery scenarios, what is still available, what might be gone in different disaster scenarios, and you should have specific focus on. We are even going that far that we have a small team that takes care of disaster recovery, so for recurring testing and other things. Good. Important also, maybe to highlight, not using hundreds of tools. You need to know these tools all need to work together, either in a flow, nitty-gritty. You need to operate each tool. Each tool needs to have access rights and so on. So keep the tool set as small as possible. Not having a tool is sometimes better than using just another tool and then struggling basically with having to maintain that, or it's misbehaving because the tool is not exactly doing what you wanted originally. And also important is, with that, in order to have a platform enabled, you need to build a golden path. You need to decide on how your shapes should look like, how your services should look like, how the platform itself will run, how a delivery will work like, because the simple GitOps approach and every development team does it by themselves with multi-cloud doesn't work. Simply doesn't work. There are too many factors, too many deviations, and one team is then updating a service which was dependent on another service and suddenly makes poof. So that's not possible. That's why you need a golden path. You need to bake it into your platform so that everybody has to follow a minimum set of rules. That's the price you basically pay for it, of course. And for that you get harmonization and an easier delivery. How could something like that look like? I've tried to put some pictures together. Andy Graber shared that slide with me. So underlaying, we have basically infrastructure, our 3 cloud vendors. On top, we are leveraging a lot of Kubernetes and also functions in Lambda. So you see the different flavors which we are using to power. There's also Rancher, because we are also using on the laptops partially Rancher, because we don't want to have this classic syndrome, works on my machine but doesn't work there anymore. So we need a Kubernetes also sometimes locally. Moving up the layer, of course, these are our services that we are using. There are also policy agents inside, autoscalers inside, and so on. And there we start already utilizing then also our own platform, because We are our customer zero. We are using our own software, of course, also in our ecosystem, and utilize that. So this is approximately the set. On top you have the consumers, so you have different people that have needs, that put requirements on the table and say, yeah, I need a new database, or I need a new node type in that Kubernetes cluster because my workload is so special. Also that is questionable, by the way. So these are services basically that you can consume, and of course also implemented for everybody. You get then certain benefits because you have security by default. It's the platform. You cannot avoid certain security checks. You cannot avoid certain quality checks. Also, for example, you get the test integration and other things when you build a platform. It's a lot of effort, of course, to get that done and get it built, but that's very important to have a solid base layer. So what's also important, yeah, we are an observability company, we observe everything, and that's maybe also something to give to you, to say, okay, try not just to observe your runtime system, try not just to observe your cloud vendor, because actually the story starts in your requirements management tooling, and then goes down the road with code repository, over build tools, certain test tools, delivery tools, the native installation API integrations, till the cloud vendors. So a strong recommendation is to have an observability solution that can tunnel all of that information basically into a single view. So, because otherwise you will have to deal with 3 different types of observability, with alert mechanisms, with different insights, and it's just more effort, it's just more work. And also the benefit what this brings is, first, you can streamline your delivery procedures, so you can work on certain KPIs that you basically get a better throughput or better resilience or better testing, for example. And on the other hand, you can start comparing, because that's what you want. You have now 2 or 3 cloud vendors, and you want to compare. What is the performance? Why is on vendor A that faster than on vendor B? No customer is basically accepting that on our side. So we need to tune the platform and the service offering that we have accordingly, and for that we need all the information, and we need that information in one system to be analyzable. Good. With that, I'm through with my presentation. Are there any questions? Anything you want to raise?
I think there are a lot of questions. So maybe to make it quicker, you start and Michael repeats it.
Okay. Patching, okay. Patching depends on, so the question was, how do we handle patching? And important with the patching is, what do you patch? So do you patch infrastructure? Do you patch a service that you consume? Or do you patch your software? These are all 3 different questions that you partially can isolate. Sometimes you can't isolate because you have a dependency, you have a relationship, for example. So what you definitely need is some type of integrated flow, so that you can say, okay, I can only roll out, for example, my Kubernetes upgrade without interfering with anything else. So you have your own train, basically, that just rolls out your infrastructure upgrade. If it comes to, for example, consumer services, you need to be a bit more careful, because if they have dependencies, and if they, because in Dynatrace, for example, Grail is our main storage product, which consists of multiple services that are heavy interwired. So you need a pipeline, you need an exact step process, for example, that you run through in order to upgrade. So when you need to patch something, you cannot just underneath rip something out. You also have maybe to roll out some software components on top at the same time. So you need always a bundle that you say, okay, this is my asset set that I now roll out, and that can contain of different assets.
There were more questions. Yeah, please.
Go ahead.
You.
Okay, so the question was, how basically did we decide to end up with cloud vendor databases while we, for example, have Kafka by ourselves maintained and hosted with Streamzy? It always depends what you expect from a service and how much you interwire with that service on which the complexity degree. So Kafka, for example, is our backbone in the system. So it's very custom made, very custom configured, and we want to keep full control basically on what we are doing there. We're performance optimizing each step that we are doing there so that our queries are fast enough and so on. So this technology to buy from a vendor is risky because normally you can get 80% out of it, but we need to go to the 99% of feature completeness and feature exact fitting to what we need. With Postgres, it was more a question about we need a simple storage where we have relational data. We are not storing mass data there. So we also not mass processing data there. This is like for documents, when a user stores a notebook or meta information, other things, they go into a database. And there we said, okay, Postgres is reasonable, that is long on the market, tested very well, and is a service provided basically from every cloud vendor, so why should we rebuild it? So there we have no such strong requirements.
So Michael, just to wrap up, I think you are going to be available a bit more today for questions.
Yes, so if you like, I know now it's lunch break, but you can also bring your sandwich to the booth basically. I will be there as well. Let's see us at the Dynatrace booth if you want to continue the talk or have some questions. Very warm welcome to discuss with me.
And at this point, I would also like to thank Dynatrace for being a gold sponsor and also, of course, supporting Cloud Native Austria and driving also the KCDs forward. So with that being said, let's thank Michael for this very detailed talk.
Thank you.
Und guten Appetit.